Hello everyone, welcome to the Daylight Project channel. Today, opening volume number 4. Yes, I already have some nails here for our experience. Let's go. So today we're going to make ourselves a train, we're going to build a train and talk about motors, okay? Electric moving motors. Yes, so very important for robots, okay? So let's get right into it. Try to shorten more the videos. So this was a duck at the time, okay? This was in 1731. Look at that. That's a long time ago. And this Jacques de Vaucanson made his own robot duck. Used to eat, used to simulate digestion, maybe even poop. I'm not sure. But that was quite impressive for the time. So man was always looking to see how to make autonomous moving objects, okay? First programming of computers, you see? The same man was responsible for the autonomous weaving machine, okay? So even the king gave him quite a lot of importance at the time. Then we also have other type of robots like George de Vol and Joseph Engelberger, okay? And they also made their own robotic arm, just like we have nowadays, okay? As you can see, these are the ones we're more used to seeing. Actually, George de Vol and Joseph Engelberger, they made actually one of the first robotic industry companies, okay? And at the time this robot could already articulate itself to pour coffee in a precise mode, and it also had like a hard disk that used to be like a big cylindrical drum, and it could memorize about 200 different movements, you see. Then continuing, we have, so for electricity we always have to talk about DC and AC, okay? AC is alternate current, DC is continuous current, okay, or direct current. So we have to talk about two different currents with electricity. We talk about AC and DC. AC is alternated currents, and DC will be continuous current, okay, or direct current. And we have both of them, as you can see right here, okay, on the schematics. There you go. So electric cars, for example, they use the DC currents from the battery to the AC motors, okay? Because they take more power out of AC motors than DC motors, because there is AC motors and there are DC motors, okay? There's two type of electric motors, but to get more power, in electric cars they use AC, okay? So for example, an electric motor, as you can see here, so this is our shaft, this is our armature, this is our commutator, and this is our stator, okay? So if you introduce here electric currents, okay, in the commutator through the brushes, in this case, it creates electromagnetic field between the stator and the commutator, okay? And because different poles, okay, attract, and the same poles tend to be opposites and repel, it will create a rotative movement, okay, because it's trying to self-balance itself, but it won't, so just keep on turning. So most electric motors on cars, for example, don't have brushes. They're brushless, okay? They work through an inductive system, okay? So then following on, we have our electromagnetic field. So if I take a coil, for example, as you can see here, depending on which way, okay, I am going to wind it up around, for example, a nail or a piece of steel, just like we have here. Okay, so as you can see, we wind it up that way. Okay, so you can put your hand there to, just because I'm holding out the camera. Okay, so our electromagnetic field, okay, the direction will be that way. Okay, because it's turning that way, like that. So with your right hand, you'll see like that, just like in the drawing. Okay, and it turns that way right there. So that's if you want to know which way will it flow. Okay, the direction of the electromagnetic field. Okay, for example, you can see it right here. So by attracting, okay, positive and negative, we are having this movement all around, and it's creating a flow, okay, an inductive flow, and that's what we have right here. A magnet also does the same thing, you see. So you'll always have an inductive flow, okay, in this case south to north. And now we have an experience to show this. Okay, we tried with the battery, but it doesn't have enough power, so we went more power. So we have our power supply over here. Just bring it more here. There we go. So we have 1.8 volts. Okay, we put our coil. Okay, we created a coil here, wind it up around a piece of just a steel thread. Okay, that just like it said here in the volume 4 magazine. So the idea, what is it? We charge it, and it's going to create, okay, for example, right now with no electric current on, okay, it's not a magnet. It has no electromagnetic field on it right now. By applying current on the coil, okay, we are going to create our directional electromagnetic field onto this rod, okay, between the coil and the rod, and we are going to be able to attract, okay, other steel components with it. So let's go. 1, 2, 3. There you go. See, look how much weight it can pick up. Okay, do it again, and it only gets out if he pulls the wire out, you see. Okay, go, switch it on. As you can see, pull the plug, there you go. So then it still remains a little bit electromagnetic, and then it loses, okay, because it's not a magnet. It only becomes a magnet with electric current. Okay, as you can see, it's actually consuming currents. We can see here. Okay, go. 8 amps, check that out. Okay, yes, it's going to heat up a bit the, actually it's not, it will heat up the coil a bit. See, it's warm, not too much, we aren't abusing it. And now applying electric current to the coil again. Okay, we are going to this is a magnet, so we will have our north-south. Okay, and we are going to turn it. This is what happens into an electric motor. Let's go. You see, so it can't attract, it's trying to balance itself by attracting and repelling. So what happens is it turns, you see, the magnet, and now it's attracted to the steel. So that's the idea of the electric motor, and we don't want to heat up too much the power supply, but yes, there you go. That's for YouTube, who cares? Okay, see, so that's how it works. So that was a good example, a good test. And now let's go and build our train, then we'll go to the software. Okie dokie, so now we are going to start to mount the train. Okay, so I got more or less all the parts I need. We still have our little box full of other parts. Okay, so each volume we get new parts. That's cool. Okie dokie, so let's get to it. Okie dokie, so we are getting there. Yes, starting to look like a carriage, let's see. Okie dokie, and voila, there you go. Our train is assembled. Ta-da! Looks quite cool. And so what I want to show here is that, okay, so it's built for rails, right? So it's all about showing us how movement works. So you don't have to have traction on all wheels, okay? So here we have front wheel drive. We have our electric motor here. And these two are going to push the rest of the whole train, okay? So it goes forward and backwards, reverse and front, okay? It doesn't go sideways. As you know, the trains also don't turn, okay? Because they're on rails. And so just like bicycles and cars, it's all about traction, torque, okay? To go faster, slower, heavier loads, lighter loads, what the use is for, okay? So let's get going. Let's test it out. Okay, so we're going to launch. 1, 2, if I can get my finger on the trigger. 3, 4, 5, go! Wow. See? There you go, guys. Got our own little train. Okay, and he's not gonna stop. So, okay, and next we have. So the fun thing is that every volume that we are doing, okay, we just keep on putting all these parts, okay, in this little box that came with the collection, and then we'll always have it for the next one. So it's a continuous work, okay? Now this time I came with eyes, and I don't know what these eyes are going to be for, but for example, it's not going to go on the train, that's for sure. So you guys have to stay tuned so that you can see volume number 5. What can it be, everyone? Surprise, surprise. And now we are going to go to our programming, which I have already fast forward, and it's already done. So it's all about creating a game, okay? So this time we have to give it commands, okay, and controls, everything. And the idea is, so I had to choose the background. I'll show you here on the computer. Okay, so this time we had to choose a background, okay, which was this like farm background. We had to create these figurines that are going to be the rats, okay, the mouse right there. So we had to give it a commands that each one goes on top of a roll of hay, okay, and then we had to put the dog here, okay, also. And the idea was to also put the cats, and this is the game, is that the cat is going to, I'm going to, with the movements of the arrows, that's why I had to say if I put arrow up, alter your direction, okay, upwards, and go 10 steps, and if you touch the dog, then it's going to be game over. If you touch the mouse, okay, that's why when the mouse gets touched, the mouse hides away, okay, and they are going to blink like on and off, but if the caddy touches one of the mouse, they disappear. If the caddy touches the dog, it is game over. So let's try it out. So it's getting more and more advanced, okay. So we have to choose tell the commands where the mouse are, okay, the coordinates. And also, as you can see here, you see, so these are the coordinates of the mouse, and we also have to say that if you touch Katie, you stop everything, otherwise you go on and off, just confuse Katie, okay. So the dog has here game over if you touch Katie. So if you guys go see the previous video, it's more or less like a follow-up. So let's try it out. Here we go. Okay, so it's always the main command when you put it in run mode. So here you are. Okay, so as you can see, the mice, the previous command that was there in green, okay, which we have here. So alternates between 1 and 3 seconds, hide away, and show yourself, okay. And also the size, go to 50% your size, okay, because they were bigger. So now if I use kitty, see, I can go right, left, down, and up, see. So I gave him these coordinates. Now if I go touch a rat, there you go, I touched that one, caught him. Now he won't appear anymore, you see. And now if I touch that one there, he won't appear, you see. 2 down, 3 to go. And did I catch him? Yes. Okay, now I'm gonna catch this one. Here we go. Boom, got him. Okay, and now remember, if I touch the dog, it's game over. If I catch the mouse, so now I can go and oh no, and I told him if it's game over, he goes back to the same position, see. And so you start everything again. So it's like this time we have to create like a small little video game, you see. So touch the mouse, touch, oh, there you go, daylight projects, game over, and go back. So it's quite cool, this follow-up of this one. So it's getting more and more evolved. And the mouse disappear, see here. Okay, there you go, see. If you touch kitty, you hide away and you stop every other movement, see. So you want to try it out? Yeah, now I'm going to pass it to someone else to play the game once. Okay, go. See if you can catch all the mouse. You can actually make it even harder, create more characters, a different background. This was just following up the magazine, okay, volume number 4, but you can even make it more complicated. You actually have to tell Katie what to do when you press the arrows, or else it won't work. There you go. See, and now if you hit the dog, there you go. Oh no, boom. Now you can create more dogs for more obstacles, okay, because you just have to like copy the dog. It's very easy. You go to the dog and you just copy, okay. You can put more dogs, but more obstacles and everything. Just be creative and have fun. So hope you all enjoyed this one. That's volume number 4, and stay tuned everyone, because volume number 5 is coming up. That's it, last page. That was the train, and boom. Okay guys, and with this, yeah, got the background. Volume 4. Stay tuned everyone, volume 5 coming up. And we are out.